Alright, hello, this time we're going to do example 6 from exercise 7.02, and it's really applications of compound interest. Areti has the opportunity to invest some money at 9% with monthly rests. How much should she invest if she wishes to have $10,000 available in 5 years' time? Alright, so just selecting my blue pen. Okay, coming back. So compound interest, let's go. A equals P, 1 plus I to the N. Now in this case, we want to know how much she should invest. So P, I don't know. I do know that in 10 years' time, she wants to have $10,000 at the end, so her amount is $10,000. Let me see, what else do I know? At 9% interest and monthly rests. So I is equal to 9 divided by 100 and monthly rests. So I'm going to multiply that by 12 because it occurs 12 times in a year. And the N is equal to 12 times, here we've got 5 years. So 12 times every year for 5 years. So if I pop these two values into my calculator, I don't need to calculate. Well, that says, hang on, that says 0. It's just a very bad one. There we go. It's not much better, I don't think. And let me have a look at 9 divided by 100 times 12 in my calculator is 0.0075. Alright, so now I've got all the values for this. I can come back and substitute them in, and we're going to be solving for P. So A, I'm just going to write that again neatly. I know that A is $10,000. That's what she wants at the end. P is what I want to find. How much does she need to invest? 1 plus 0.0075 to the power of 60. They're still wobbly, those zeros. Here we go. I'm going to try it neatly. There we go. 0. So if I put that in to my calculator, now this is just a number. So I'll swap this pen around. Okay, so you can actually put this section into your calculator first, and I would do that. So going back to blue, you'll end up, and you can divide it straight through. But we'll put it into our calculator first. That's multiplied by, that value comes out at 1.5656. Now I can divide both sides by this 1.5656, so $10,000 divided by 1.5656 is equal to the P. So the P would be equal to, when I put that this into my calculator, it ends up being $6,387 that Areti needs to invest right now to have $10,000 in 5 years' time. So therefore, needs to invest. Don't hit the rubber. Now I've got something ridiculous there. Hang on. Needs to invest $6,387 to have $10,000 in 5 years with monthly rests. So you can write that out formally and beautifully, much nicer than I can on the tablet. Alright, so that's A. In example 6, there's also B, so I'm going to slide that up and we'll do B now. Alright, this one, we're obviously going to use the same formulas. We're applying, let's have a go at writing that more neatly. A is equal to P, 1 plus I to the N. 2 years ago, that's supposed to say Tan, but it autocorrect making it than. Tan placed $8,300 in an investment account with quarterly rests. If his money has grown to $9,500, What interest rate, so I'm looking for the interest rate this time, per annum did he earn? All right, so we know that if we look at the amount, he's now got 9,500. Oops. The principal that he invested was, he placed 8,300. The interest rate is what I need to find. Okay, but I do know that it's equal to the rate divided by 100 times the number of rests, and it's happening 4 times a year. Quarterly rests means 4 times a year. So I'm going to leave the I as that value, which is going to be simplified as R over 400. And N is 4. It happens quarterly rests. How many years? 2 years ago. So we're going to say it's been invested for 2 years. So that's going to be equal to 8. Now, with all the things that I know, I'm going to put those back into the formula. So the A is 9,500 is equal to, I might run out of space here, 8,300. 1 plus, now I is what I'm looking for, but remember we're finding interest rate. And that's this formula here, the I, and all of it is taken to the power of n, and n was equal to 8. Alright, so the first thing I can do is divide 9,500 by 8,300, and that'll give me on this side 1 plus R on 400. And don't freak out, this is not as tricky as it looks, it's just one step at a time. Okay, so I can do this part on my, I'm showing you on my, I can do this on my calculator, and that'll be equal to 1.1445. So when I divide 9,500 by 8,300, I get 1.1445 is equal to, now I've got all of this, and it's still all taken to the power of 8. Alright, so now I can find the 8th root. Now that's a button on your calculator. So you need to find, on your calculator, I think, it's a second function, and I think it looks something like this. I haven't got my green calculator at home right now, but I think that this is the calculator button you're looking for. And you need to then put in, this is where the x is, you're going to put an 8. So you don't want a square root, you want the 8th root. The 8th root of that is equal to 1 plus R over 400. Alright, so when you've managed to wrangle that on your calculator, the 8th root of 1.1445 is equal to 1.0170. Is equal to 1 plus R on 400. So no panicking. Now we're going to take away the 1 from both sides. So 1.0170 minus 1 is equal to R on 400. And that's pretty easy. So that's equal to 0.0170 is equal to R on 400. And, oops, just sliding up again. This is so much easier than a whiteboard. Now, the last thing I want to do is multiply both sides by 400. So 0.0170 times 400 gives me the rate of interest as a whole number. So R is equal to 6.81. Therefore, the interest earned. Oh, I've gone into bubbling out mode again. The interest earned is 6.81%. Fantastic. That wasn't as tricky as it looked, was it? All right, good luck with that.